Good afternoon, everyone. My name is Dominik Maźniak. I'm a student of Masters in Electrical Engineering and Information Technology at UM, and I'd like to present my research internship project in the topic of integration of BLE sensors into CTG Mobile Fleet connector. The internship was supervised by the company Trium Analysis Online. In the light of the COVID-19 pandemic, remote CTG monitoring has become increasingly important. Due to social distancing and quarantine measures, pregnant women were unable or hesitant to visit hospitals and clinics for regular checkups, resulting in a potential gap in the monitoring of fetal health. Thus, developments of home fetal monitoring technologies accelerated in the last years. The integration of additional maternal vital data sensors apart from uterine contractions and fetal heart rate takes remote as well as traditional CTG monitoring to the next level, providing physicians and midwives with more comprehensive data to help them make informed decisions regarding the care of their patients. For instance, explicitly measuring maternal heart rate in addition to fetal heart rate gives them a benefit of filtering out the two vital data points from each other, so we can avoid identifying one for the other. In this presentation, we will talk about how a home fetal monitoring system can be extended by such sensors to provide greater insight into the fetal and maternal health. The research project is about extending the existing application developed by Trium called Trium CTG Online, which is a web-based platform utilized for monitoring fetal and maternal health in a clinical setting as well as telemedicine. The idea is to provide an Android application, the so-called Mobile Fleet connector, with capabilities of collecting fetal and maternal vital data and its communication with the web server. Let us delve into the high-level architecture of the remote CTG monitoring process. The mother initiates continuous CTG monitoring at home, and the physician remotely accesses the data by utilizing the Trium CTG Online platform. The patient will wear sensors measuring fetal activity as well as devices providing maternal heart rate, oxygen saturation, and blood pressure. The BLE sensors are paired and connected to the Android smartphone backend, where the data is aggregated and displayed in the user interface. Furthermore, the data is transmitted to the CTG Online remote server, where physicians or midwives can access the data and charts later to determine further courses of action, such as potential treatments. The data can also be analyzed by decision-making support systems, which are based on anomaly detection and prediction algorithms. This can assist physicians in making optimal decisions. One of the main requirements of the task, apart from solely technical requirements, was the application to be device agnostic. It means that any sensor providing a specific type of vital data should be able to deliver the information to the application out of the box just after pairing it over Bluetooth Low Energy. In other words, loose coupling should be provided. The solution to this requirement is utilization of Bluetooth Low Energy profiles, where every commercial device providing specific type of data should also implement a corresponding type of Bluetooth profile. On a high level, BLE devices publish data to profiles predefined during their manufacturing, such as heart rate or blood pressure, which then can be easily subscribed to by a smartphone. In the slide, you can also see which sensors we used for the proof of concept. A widely known issue is that many manufacturers do not adhere with the standard, so that their devices can only be used with their dedicated apps. It is the case with pulse oximeter Maxima MightySat, which only implemented custom profiles, so its reverse engineering or hacking was necessary just for the purpose of the POC. Now we will present the POC demo on the video. When the user opens the app for the first time, they will be prompted to specify settings such as the address of the remote CTG Online server and pair all the necessary devices over BLE. We select the devices by the vital data type. After it's done, you switch to the main app window. You can select either online mode of operation, meaning the data will be sent to the server, or offline type, where no internet connection is necessary. We go for online. Now we get the chance to take the first measurement type, which is blood pressure. If you want to take the measurement, you trigger it by pressing the button on the on-run device. Once the measurement is done, the app will receive it. While we are waiting for the blood pressure measurement to be taken, take a look at the CTG Online portal on the right bottom side. You can see multiple windows, each of them containing CTG measurements of different patients. For us, Charts will be shown in the upper middle window. The measurement is done. On the right forearm, you can see polar OH1, which is measuring heart rate. Now we press Go to CTG to trigger the actual CTG monitoring process. The app starts receiving the data and automatically transmits it to CTG Online together with previously taken blood pressure. You can also take the blood pressure measurements asynchronously if you wish. We will now fast forward 10 minutes of the measurement session in order to show you the end result. The CTG Online report is ready, which contains all the data that's been measured. In the real scenario, it will be accessed remotely by a physician or midwife or used for AI inference. That's the end of the presentation, and thank you for your attention.